Hi, so we've done color addition with the colored shadows. Now we want to talk a little bit about color subtraction and color addition. This type of question, I call it the actor's clothing question. This is an A-level question, and it's really about logic. It's if you can think your way logically through saying if A then B, if B then C, then you'll be able to figure this out. What's helpful is if you have that grid, that 6x6 grid available of what the colors add up to, you know, this color object with this color filter. So even if you don't have that, we can get it figured out. So let's say this is the setup we have. What this is, in one situation, we have actors' clothing, their torso, their shirt looks black, their one leg looks yellow, their second leg looks green. Then we change to a different color filter on the light shining, and now their shirt looks blue, this leg looks green, this leg looks green. Your job with these questions is to figure out what color filter is shining in this case, what color filter is shining in this case, and what are the actual colors of the three pieces of clothing. So you have to fill in these 5 boxes. And it's going to be just, there's multiple ways to solve these, but it's all some sort of logic process. The first thing that I do always with these is I look for yellow, cyan, and magenta. Because with these colors, with these secondary colors, the only time you'll ever see a yellow object is if the object is yellow. So we have to have a yellow object, and we have to have the filter being yellow. Same thing with cyan. If you see something as cyan, both the object and the filter have to be cyan. So I always look for yellow, cyan, and magenta first off, because that gives me 2 pieces of information. So here, look at that, right there. I have yellow. So if I see something as yellow, the only way I can see it as yellow is if the filter that's shining, the light that's shining on this is yellow, and if the object itself is yellow. So that's my first step, always. Look for yellow, cyan, and magenta, because that gives you 2 of your 5. It gives you the filter color in that situation and the object. And after that, you have a lot of choices for how to solve this. Often what I do next is I'll look in the trios here and say, well, do I have multiple colors visible? Here, I have black visible, I have yellow visible, and green visible. Well, green is a part of yellow, so that doesn't really tell me anything because I know that there's yellow light here. And yellow light means that the red and the green are getting through. The only thing that's blocked here is blue. So having yellow plus green doesn't tell me anything. How about here? We're seeing blue light and green light shining here. Now that does tell me something. If we have blue light that's visible and green light that's visible, then we know that this color filter has to let blue and green through. The only color that is going to let both blue and green through is something that is a combination of blue and green. Blue plus green is cyan. So this filter for this situation, the light that's shining on this must be cyan light because it lets both blue and green through. Now cyan light, if it lets blue and green through, it's subtracting red. All right, so I know with my filters that this one's taking out the blue and letting red, green through. This one's taking out red, letting blue and green through. Now at this point, I still have to finish off these 2 objects. So what is the color of the shirt? What is the color of this pants leg? All right, so let's think about the shirt. We have black in this situation and blue in this situation. I know that it must contain blue because there's blue light shining in some version of this. So some point it has to contain blue. If I look at this situation, I see that with a yellow filter, yellow filters out blue and only blue. So if yellow is filtering out blue, the only thing that would look black under a yellow filter is something that would be purely blue. So this object must be blue, just straight up blue, because it has to have blue in it. We know that from here. And if it had any red in it, that red would have shown up here. If it had any green in it, it would have shown up here. It didn't. So it was purely blue, and all of the light got filtered out, leaving it looking black. So that top, the shirt, must be just straight up blue. So our last piece is the color of this object. And here we know it has green in it. All right, so it has green. And, well, okay, both of these have green let through, so it's not going to be helpful. Let's figure out what colors have green in it. Well, it could be just straight up green. It could be green plus red, which would give me yellow. Or it could be green plus blue, which would give me cyan. Those are the three colors that have green in it. All right, so could it be any of these colors? Well, if it was cyan, if it was a cyan object, then it would have looked cyan under a cyan filter. So if it was cyan, it would have looked cyan here, and it doesn't. So we know it can't be cyan. Similarly, if it was a yellow object, it would have looked yellow here, just like this thing. It would have, if we had yellow and yellow, it would have looked yellow and yellow. So it can't be yellow, which suggests that it has to be green. All right. At this point, I like to just double check and make sure that all the things match up. So a blue object. So if we have something that is blue, what would it look like under a yellow filter? Well, yellow filters out blue, so blue minus blue equals black. Good. Blue object under a cyan filter. A blue object, blue is allowed to pass through, it should look blue. Good. Yellow object, a yellow object with a yellow filter should look yellow. Yep. And a yellow object under a cyan filter. So a yellow object, but we subtract out the red. Yellow is red plus green. So if we have red plus green light starting, and then we subtract the red plus green minus red, we should get green. That matches up too. And then the last one, we have something that is just straight up green. So under a yellow light, the green light gets through, it looks green. Green object, the green light gets through under a cyan, looks green. So it all matches up. If I just kind of make sure everything is matching up, it looks like it's good. We have consistency among all 5 of our objects, so I think I've got this right. So that's the way to solve these actors' clothing problems. Now this is an A-level problem, and it's really logic. There are multiple ways to get to the right answers. But the first step that I recommend in any case, I recommend looking for yellow, cyan, magenta, because that gets you 2 of your 5 unknowns right off the bat. Because any of these 3, it tells you the object color and the filter color. They both have to be yellow, or they both have to be cyan, or they both have to be magenta. So we've got those first, and then after that, kind of work your way around saying, well, if it's this, then it has to be that, and it can't be this, so like this one, can't be cyan, can't be yellow, must be green. So there's lots of ways to solve these, but in general, it's just kind of a logic problem, and you're using the ideas of color subtraction and color addition in order to figure out what colors the actor's clothing actually is, and what colors of filters we're shining on the actor's clothing in order to see these colors. So that's actor's clothing problem. So, good job.